Okay, so I have a complex fraction, but this one's very complex because I have two fractions in the numerator and two fractions in the denominator. Alrighty, so I know this bar means division, and I know I need to rewrite division in fraction land as multiplication, but I can't do that yet. I can only rewrite this as multiplication when I have one fraction in the numerator, one fraction in the denominator. Okay, no big deal, we can fix this. We've already learned and mastered how to add fractions and subtract fractions. We know adding fractions easy as can be, all you need is an LCD. Do I have the same denominator? No. So I need a common denominator for 3 and x. Well, they're both prime. 3 is in lowest terms prime, x is in lowest terms prime. So the common denominator would be that number times that variable, so it would be 3x. If I change the denominator, I got to change the numerator. How does a 3 become 3x? Well, I had to multiply by x, right? If I want this 3 to become this, I have to multiply by x. So this numerator is going to be 1x. How does this denominator change to this one? How do you make an x become a 3x? Well, I had to multiply by 3. So this numerator is going to be 1 times 3, which is 3. So adding fractions easy as can be, all you need is an LCD. Got it. If you change the denominators, you must change the numerators. Got it. So now you write the bottom, 3x, you collect the top, x plus 3. Can you add those expressions? No, you cannot add those monomials. They're not alike. That's the beginning of the course. Can we reduce? Well, reduce means to do division. 3x is connected by division, but x plus 3 is not. Can you factor an x plus 3? Well, there's no GCF. It's not a difference of perfect squares. It's not a trinomial. So we cannot factor the numerator. Therefore, we can't do any reducing or dividing. That is our fraction in the numerator. Now we're going to go to our denominator. Okay? It says subtract. First thing I know, subtract means to add the opposite. The opposite of 1 is -1. Adding fractions easy as can be. All we need is an LCD. 2 and x are not the same. What would be the common denominator? Well, 2 is prime, x is prime, so 2 times x would be a common denominator of 2x. All right, we changed the denominator. How does a 2 become a 2x? We multiplied by x. So 1 times x makes our numerator x. Here's our old denominator, x. Here's my new denominator, 2x. How does x become 2x? I multiplied by 2. So -1 times 2 is -2. So now all we have left to do to add is write the bottom, 2x, collect the top. X plus -2 is written as x minus 2. Remember in algebra, you do not write two symbols in front of a number. If you write in algebra x plus -2, you're going to get marked wrong. This 2 is negative. I don't need that plus. That plus just means put them together. I can't put these terms together, they're not alike, so I just write them side by side in the correct descending order. Okay? Never, ever, ever give me a number or a letter with two signs in front of it. All right, now we're supposed to divide. But to divide, I got to be connected by multiplication. X minus 2 is not multiplication. So can we factor that? Is there a GCF? Nope. Is it a difference of perfect squares? It's a difference, but x and 2 are not perfect squares. It's not a trinomial, so we cannot factor it, therefore we can't do any division. So now look guys, this fraction bar was in the middle of all this work. What you've done now is you've made one fraction bar in the numerator, one fraction bar in the denominator. So now this says to divide. But we know there's no such thing as dividing in fraction land. We multiply by the multiplicative inverse, the reciprocal. So the first fraction stays x plus 3 over 3x, and we're going to multiply it by its reciprocal, 2x over x minus 2. So now that we got it as one fraction over one fraction, and again, you know it's one fraction. There's one fraction bar, there's one fraction bar. If you go back to the original, 2 fraction bars, 2 fraction bars. So we know now we have 1 fraction. Now we can rewrite it as multiplication. Now, can we do any reducing? Remember, multiplying fractions is no problem. Top times top, bottom times bottom. Before you start to multiply, factor first, then divide. You've already told me we cannot factor x plus 3. But Ms. Black's going to put it in parentheses to show we're glued together. We cannot factor x minus 2. You already told me that. I'm going to keep it in parentheses to say those terms are handcuffed, glued together. The only thing that we can divide is this x with this x because they're connected by multiplication. So they're gone. So in my numerator, I'm left with x plus 3 times a 2, which I'll put in front, proper order. And in the denominator, I'm left with 3 times x minus 2. If this was my class, I would allow them to leave the answer in factored form. I like that when it's all connected by multiplication. If your professor or whoever you're working with wants it simplified more, then you'd multiply. 2 times x is 2x. 2 times 3 is 6. 3 times x is 3x. 3 times negative 2 is negative 6. And that fraction means the same thing as the factored form. So just know what your professor is expecting from you. And now we are done with fractions. I'll see you in the next module where you learn something totally new. Have a great day.